See, this is one of the applications on center of mass reference frame. Okay, that is let us see that it is in DPP 1 now. Right. Question number 19. Two small discs A and B are connected by an inextensible string of length pi l. Mass of ball A is m and that of ball B is 2m. A is m, B is 2m. Got the points? Clear. The balls are resting on a frictionless horizontal surface with the distance between them 3l. With the distance between them 3l. Okay. In this position, ball B is given a horizontal velocity u perpendicular to the y joining two balls. Okay. In this position, you see the length of the string is actually phi l, but now the distance between A and B is only 3l. Under these conditions, the ball B is given a horizontal velocity u. Okay, right? Perpendicular to the y joining the two balls. This velocity is perpendicular to this now, the line joining these two. Okay, clear. Now, first question is find the speeds of the ball A and B just after the strings get starts. You see, find the speeds of ball A and B just after the string gets start. When string gets tight, tension comes into picture. Okay. You see, previously we have gone through some applications of this. When string is taut, we worked out from center of mass reference frame now. Yes, from center of mass reference frame, if you work out, angular velocity of the connected bodies will be same now. For both the bodies, angular velocity will be same. For both the bodies, angular velocity will be same. From which frame? Center of mass reference frame. What the point? Is it clear or not? That's what. So you see, find next question. Find the impulse of the tension in the string when the string becomes taut. Okay? Find the impulse of the tension in the string. Okay? When the string becomes taut, means what? Find the impulse of the tension in the string. Means what? The tension is going to change the momentum. Okay? That momentum, that change in momentum is asking. Okay? That is impulse of tension. Impulse is nothing but change in momentum now. Yes. Right. Next, find the steady tension in the string just after the string gets taut. This is much often not. Just after the string gets taut. After getting taut, string after getting taut, tight. Okay? Clear. At this, under that condition, what is the tension in the string? He is asking. These three questions he is putting before us. Okay. You see, we can first of all find the speeds of the ball A and B just after the string gets tight. That is the first question we are going to. Let us go with this first question. Right. Let us see once. This is A, whose mass is m. This mass is 2m. The length of the string is phi l. But what is this distance now? 3l. Now, this is horizontal smooth surface. What better? Horizontal smooth surface. Okay? Clear. Horizontal smooth surface, I will consider A and B as a system along with the string. If tension appears, the tension force will become internal force or external force? Internal force. The tension force will become an internal force. So, internal force no issues. We can conserve momentum in a specific direction now. So, for this system, we can conserve momentum in a specific direction. That is horizontal. Okay, along in the horizontal planes, if we go with a, if you want to conserve momentum along a given direction, we can conserve it. Yes or no? Yes. Now, when it starts moving, what is going to happen? When it starts moving, you see the relative positions of B will be like this with respect to A. Yes, sir. At one moment, what happens to the string? If It will become tight. What nana? 5L. It will become 5L. This remains, this length becomes as it is now 3L. Okay, now let us see what is going to happen in the next situation. This is what beta? 3L. This is 5L, means this is obviously 4L. This is some 37 degree. Okay, opposite to 3L. Opposite to 4L is 53 degrees. This is 90. Okay, this is a known thing for us. Now this is just before the string is stopped. Okay, clear? Now, along this length of the string, I am taking it as my x-axis. Perpendicular to the length of the string, I am taking it as y-axis. X-axis and y-axis. Is it clear or not? Now, can you say, along the length of the string, the velocities, the relative velocity should be 0 for both the objects A and B, because string is inextensible. String is inextensible. So along this direction, the velocities should be same. Yes, the speed should be same. Relative velocity should be 0. Clear? Suppose if its velocity along this direction is more than this, then the length of the string should increase. It doesn't happen. It doesn't happen. Okay? Right. Let us go for the things now. This is just before the dot. Just before it is tight. Just after dot. What is going to happen? Let us see once. Now, this is A. This is B. You see beta, U. This is also 37 degree. This is also 37 degree. Clear? Now, along this direction, x direction, what is its velocity?
Cos 37.
U cos 37. U cos 37 means what? 4 u upon 5. Perpendicular to this is 3 u upon 5. This is just before dot. Just before dot. Okay? Is it clear or not? Now, just after dot, this A and B should have same velocity along which direction? X direction. This is x now? Yes. Let us go for the diagram also. A, M, this is B, 2M. Now, tension comes into picture. Tension comes into picture here, just after dot. That is just before dot. Tension is not coming into picture, just before dot. Okay? This is just after dot. Means tension comes into picture. And this velocity will be affected by the tension force. How the tension force and this velocity? Perpendicular. This velocity of B will not be affected. What is the velocity of B? 3u upon 5. 3u upon 5. Is it clear or not? Sure. Now you say, along this direction, both should have same speeds or different speeds? Same speeds. Okay? Just after dot. Is it clear? Now, along x direction, this is what direction beta? Along x direction, can I conserve linear momentum? Just before dot and just after dot. Can I conserve? Sure. So, just before dot is what is the situation here? This is the situation. Okay? This is the situation. You are able to understand? Just before dot. What is the momentum along the x direction? 8 mu. This is 2m now. This is 2m. 8 mu upon 5. So 8 mu upon 5. This is what? Momentum along x direction of the total system just before dot. Just after dot. 3 mv. 3 mv. Now can you say about V?
8u upon 15.
8u upon 15. This is what? This is 8u upon 15. 8u upon 15. Yes? Just after the thought, the velocity of A is 8u upon 15 I cap. B is 8u upon 15 I cap plus 3u upon 5 j cap. Very simple issues. So what is asking here? Find the speeds of the ball A and B just after the string gets stopped. Okay? Clear? Just after that. Speeds is asking. Magnitude. Let us go for calculation. Let us see this. Now listen better. 8u upon 15, 3u upon 5. What is the magnitude of the total velocity for this? Under root 8u upon 15 whole square plus 3u upon 5 whole square. This is 8u upon 15 I cap. For A, velocity is 8u upon 15 I cap. That is, magnitude is 8u upon 15. But what about B? Yes, under root. This is x component, this is y component of the velocity. The velocity is like this. Okay, what is the magnitude? 3u upon 5 whole square plus 8u upon 15 whole square. How much you are expecting? Yes, how much you are expecting? 25 to 25. Okay, you बाहर निकलते 9 upon 25 plus 64 upon 225. How much you are going to get?
145 square upon 225.
Yeah, this is 25. How many times? 9 times. 81 plus 64 I hope. 140? Approximately 144 level. Upon 225. 225 means what? 15u. This is the speed of B. This is the speed of B. Okay? Clear. This is x component, this is y component. Under root bx square plus vy square. In your vectors you learned. So what about this 8u upon 15? So we got sub question 1. What are the speeds? The speed of ball A is how much? 8u upon 15. The speed of ball B is what? Just after the spring is stopped? 12u upon 15. I hope so. Is it clear or not? Issue is so simple now. Okay. Now let us go for second question. Find the impulse of the tension in the string when the string becomes taut. Impulse of the tension means change in momentum just before taut and just after the taut. Just to find the change in momentum of A or B. Of A or B. So that is nothing but impulse of tension. Impulse of tension force. Got the point? Is it clear or not? Sure? Yes, that's what. Let us go for that. Now, yeah, what is the initially, what is its initial velocity? Just after the dot, just before is 0. Yes. Just after 8u upon 15 I cap plus 3u upon 5, sorry, 8u upon 15. So what is the change in velocity, change in speed of A just before dot and just after dot? 8u upon 15. This is before, this is after. So momentum, change in momentum is nothing but? Yes, change in momentum is nothing but mass times final velocity minus initial velocity for A. So m is how much? M itself. V is what? 8u upon 15. U is what? 0. So 8mu upon 15. This is what? Change in momentum of A due to tension, impulse of tension. So if you calculate for B, you are going to get same thing or different thing? Same thing, because tension is going to influence only, yes, along x direction, change in velocity. It is not going to influence this direction now. Yes, what you will take? What you will take then?
2m.
Yes, 2m into final is what? This 8u upon 15 minus initial is 4u upon 5. So 2m into for B. B is what? 8u upon 15 minus 4u upon 5. What you are going to get?
4u minus
2m?
2m into 4u upon
5 3s are 12. How much you are going to get? Minus 4u upon 15. Means what you are going to get? Minus 8u. Means what? Change in velocity is decreased. Speed is decreased. The speed is increased. That is the only difference. Why we are getting negative? Impulse negative means what? Change in momentum is negative. Means speed is going to decrease. Issue is so simple now. Is it clear or not? So this is what? This is what? Okay? 8 mu. 8 mu upon 15 is nothing but for both A and B. This is for B. This is for A. You are getting same answer or different? C. So that's why what he mentioned is find the impulse of the tension in the string when the string becomes taut. When the spring becomes taut. Okay? When the spring becomes taut. So you see, find the impulse of the tension in the string when the spring becomes taut. So what is that? 8 mu upon 15. 8 mu upon 15. This is 8 mu upon 15 in the second subquestion. Next we shall go for the third one. Okay? Find the steady tension in the string just after the string gets taut. So tension बोले तो किस फ्रेम से वर्कआउट करना? सेंटर ऑफ मास फ्रेम से वर्कआउट करना. हम पिछले सेक्शन में सीख लिया. Yes, we learned in our previous session. Okay, clear? How to work out from center of mass reference frame. Just after the taut means we should work out from the center of mass reference frame just after the taut. Just after the taut means you see this. You see, this is just after the taut now. This system, A and B system. A is having what velocity? 8u by 15 I cap. B 8u by 15 I cap, 3u by 5 j cap. So this is just after the taut. This is a system. Okay, tension will be there in this. And this is from which frame? Ground frame. These are the velocities from which frame? Ground frame. So same for the same system, just after the taut, we should draw diagram for, yes, from the center of mass reference frame. Clear? Just after the taut, this is from ground frame. This situation is from ground frame. Means just after the taut, from the ground frame, the person will see 8u by 15 along this direction. The ground frame, from the ground frame, the person on the ground frame, what he observes about B just after the taut? 8u by 15, 3u upon 5. These are the velocities observed by ground frame observer just after the taut. Now how a center of mass observer feels, let us see once. If we work out from that, we can evaluate tension in the string. Let us go for that. Let us see once. Okay. Right. Let us go for that now. You see, in this case, velocity of the center of mass for this system is going to change or not going to change? Not going to change. Why? Very good. There is no external force along x direction. Okay, there is horizontal. So, center of mass is not going to, velocity of center of mass is not going to change for this system. So, at any situation, just before taut, just after taut, whatever it may be, velocity of center of mass is constant. Same. Okay? You know this condition, I hope so. Let us go for those conditions now. Can you calculate the velocity of center of mass here? This is x, this is y. Now you see, velocity of the center of mass is, this is m, this is 2m. Nothing is there, velocity. Okay? This is just before taut. Whatever it may be. Can I calculate now? Velocity of center of mass before taut or after taut will be same or different? Same. Now, next 2m into 4u upon 5 I cap m1 v1 0 m2 v2 means what? Plus 2m into 3u upon 5 j cap upon 3m. This is what? m1 v1 is 0, m2 is 2m times velocity. Calculate this. Okay. Now 8u upon 5 I cap plus 6u upon 5 j cap. What is this?
By 3.
By 3, sorry. Upon 15, no? Sorry. Okay. So this is velocity of center of mass. Velocity of center of mass. Okay. Now, to calculate tension, we are supposed to, okay, work out from which frame? Center of mass reference frame. Let us work out from center of mass reference frame. Sure. Just after the thought, just after the string is taut, this is from which frame? This is from ground frame. After thought, this is from ground frame. Let us work out same diagram from which frame? Center of mass reference frame. Can I? Yes, I will do that. You see. Can I clear this? Now, this is from ground frame observer. Which frame observer? Ground frame. After the thoughts. Same. I will go with A, that is M, B, that is 2M. Center of mass will be near to 2M. Total length is 5M. 1:2 ratio. Yes. This is 1 ratio, this is 2. Means what? How many parts we should make 5L into? 3 parts. 5L upon 3, 5L upon 3, 5L upon 3. This is 2 parts. This is 1 part. 2 into 5L upon 3. This is how much? 10L upon 3. This is 5L upon 3. You are able to understand? Yes. This is center of mass. Now person is attached to whom? Center of mass. Okay. What he will calculate? This is my x-axis. This is my y-axis. Velocity of A with respect to center of mass is velocity of A minus velocity of C. Velocity of A minus velocity of C. Now, the center of mass observer want to calculate the velocity of A. Means velocity of A with respect to center of mass. Now you say velocity of A is how much? With respect to ground now. How much? AU upon 15 I cap minus. What is that? Velocity of center of mass. AU upon 15 I cap minus 6U upon 15. Yes, you are wonder kids. So 6U upon 15 minus J cap meter per second. Let us take velocity of A with respect to C. Now, with respect to center of mass observer, what he feels about A? 6U upon 15 velocity perpendicular to the position. Is it clear or not? Now, with respect to center of mass observer, what about Mr. B he will feel? Let us go for his feeling. Yes. What is his observation? Center of mass observation about B. Velocity of B with respect to C. Velocity of B minus velocity of C. How much? Velocity of B is how much, Nana? Just after the thought. Just after the thought. Velocity of B with respect to ground observer BB. How much? 8U upon 15 I cap. 3U upon 5 J cap. So 8U upon 15 I cap plus 3U upon 5 J cap minus 8U upon 15 minus 6U upon 15 J cap. अरे यार ये चाहते क्या नहीं करते? How much? 5 3s are how much? 3U upon 15 J cap. Yes. U upon 5 J cap. U upon 5 J cap. This is whose observation? Center of mass observation. The center of mass observation on which block? B. 2M. So it is in which direction? J direction. Like this. This is U upon 5 meter per second. This is minus J cap, that is J cap. Now, from this center of mass observer frame, again, Yes, what analysis we will get? A is moving in circular path, B is also moving in circular path, because the position vector of A with respect to center of mass and the velocity are perpendicular. And what you can say now, the angular velocities of A and B with respect to center of mass frame is 0. See, equal, sorry. What are equal? What are equal? So A should have same angular velocity with respect to center of mass, and B also should have same angular velocity with respect to center of mass. Now, center of mass observer is what is his observation about A? It is moving in circular path. For a particle to move in circular path, there should be some center seeking force. It will provide necessary centripetal force. Which will provide now necessary centripetal force? Tension. What nana? Tension. Okay. From here to here is the radius. From center of mass position to A is radius. So tension will provide mr omega square. Okay. M is what for A? M itself. Radius is how much from here to here? 10L upon 3. Now you say what is omega beta for this? Omega is V upon R. V is what? 6U upon 15. R is what? 10L upon 3. Is it simple now? Okay, what you are going to get then? 6U upon 15 upon 10L upon 3. 10L upon 3 whole square. Can't you calculate this? Can't you calculate this? Obviously you can calculate. How? M 10 upon 3, 10 upon 3 will move away. Okay? Clear. L will remain. U square. Mu square upon L. So what will be remained? 36 upon 225 divided by 10 upon 3. How much you are going to get that? How much? 5 2s are, yes, 36 into 3 upon 10 into 225. How much you are going to get? Mu square upon L. 36 into 3 upon 225 into 10. How much?
Square upon 1125.
Yeah. What you are going to get? Cancellation. Something you can go for cancellation. 2 5s are 2 8s are. Any more cancellation? 3 75. So how much you are going to get? 18 mu square upon 3 6 are 325. So how much you are going to get then? 6 mu square upon 25 5s are 125. That's all, no? Yeah. Sorry, 125. Yeah. What is this 6 mu square upon 125? L is what? Tension in the string. Okay. So we have evaluated what here? Yes. Find the steady tension in the string just after the string is torn. So first we evaluated what? Yes, speeds. Okay. By what? Conservation of linear momentum along the string. Okay. Second, impulse means we calculated change in momentum of A and B. We got that. Third, we worked out from center of mass reference frame. Okay, beta. You understood the application? Right. Thank you.